Thermofluctuation constants of built-up section wooden beams without. The thermofluctuation concept of destruction and deformation of solids appeared in the middle of the last century and became the next step in the study of destruction and deformation mechanisms. In the thermofluctuation concept, the destruction of a body is considered as a thermoactivation process that develops over time when a load is applied to the body. It reduces the binding energy, which in its turn leads to a change in the distance between the atoms. Consequently, with an increased mechanical field, the process of breaking interatomic or intermolecular bonds accelerates. The directivity of the applied load makes this process irreversible due to the accumulation of elementary discontinuities. During the experimental study of temperature-time dependence of strength, Zhurkov derived a formula for determining the durability of the material. The development of scientific foundation of the thermofluctuation concept allowed one to explain the mechanism of destruction and reveal the physical meaning of the constants included in the resulting formula. Later, Ratner and Yartsev modified the formula by introducing a limit on the maximum temperature at which a material can work, while the physical meaning of constants and the interpretation of heat motion of atoms as the decisive factor of destruction remained unchanged. To predict the durability, it is necessary to experimentally determine the thermofluctuation constants for each material. At present, these constants are determined for a wide range of building materials, including for wooden elements. However, in the case of built-up sections, constants may differ from the constants of solid section. Therefore, this work concerns determining the thermofluctuation constants of built-up section wooden beams. The built-up section elements possess different heights. Two variants of the element's arrangement relative to each other are considered. Subsequently, according to the test results, the empirical constants included in the generalized Zhurkov equation were determined by a graphic analytic method. The short-term strength for the first variant was determined at temperatures of 10, 20 and 33 S, for the second variant 15, 25, 36 degrees Celsius. The results are presented in table. From the results obtained, it can be seen that the higher the temperature of the test, the less stress must be created in the material for its destruction. During the tests, it was noticed that the samples have a different nature of destruction. Some built-up components broke down with the rupture of wood fibers at the place of load application, the others, under significant deformations. Based on the results obtained, the thermofluctuation constants for the first variant of built-up section sample were determined by means of the graphic analytic method. It should be noted that for built-up section wooden beams, as well as for solid section wooden beams, the inverse sheaf is implemented. The constant is presented on the slide. The results of durability test for variant 2 are summarized in table. Based on the results obtained, the thermofluctuation constants for the second variant of built-up section sample were determined through a graphic analytic method. The constant is presented on the slide. The obtained constants are summarized in table, which also shows the constants for a solid wooden section. Based on the above said and the results obtained, the following conclusions can be drawn. Constants activation energy and structural and mechanical constant, when compared with the results obtained for solid section samples, do not have a common factor. At the same time, based on the results of table, we can see that the modulus for activation energy is about 2 times greater than the modulus for structural and mechanical constant. Perhaps this phenomenon is also a dependency and requires further clarification.